good to me. Okay. Ah, where did it go? Okay. So. Okay, part 2. Question. Okay. One of the professors in the BYU Idaho math department collected data from BYU Idaho students to compare the mean average wage mean wages of BYU Idaho male students to BYU Idaho female students. The students from his class completed a survey which he then used to analyze if there was a difference in the wages. What is the research question? The difference between the means. Or, if we're being proper, JK.
Is Cassie not here anymore?
You there? Rebecca? Can you see me?
Sorry, this is one of those days that if it can go wrong, it will go wrong.
Oh.
Okay.
I was like, why isn't she answering? I'm like, I'm pretty sure that's the answer. Why isn't she agreeing with me?
Yeah, no, it just like shut down all of a sudden.
Okay. No worries. Okay. So did you hear me read the entire thing?
I heard you read about half of it, but I can see the rest of it.
Okay. So anyway, the research question is if there's a difference between the wages.
Yeah, and then null and alternative. Null is that they're equal, and alternative is that they're not equal.
Yes. So, collecting the data, describe the data, just that they were asked about the wages,
Yeah.
right? Like,
This is the survey, yeah.
okay.
Okay. Got the data for males. The mean was 11.935. The standard deviation was 10.49. The number was 88. And for females, the mean was 9.7594. The standard deviation was 3.169, and the number was 91.
Yes. Okay. Ugh, I just lost it. Okay. So what type of hypothesis test is appropriate? I went back to the thingy, and I think it's independent.
Yeah, that's what the answer key said. That's what I was thinking.
Okay.
Too. And that's what the unit is, so I pretty much assumed it would probably have to be.
Yeah. No kidding. Okay.
Okay, and the requirements are met because it's large enough that we can assume it's normal and it was from a simple random sample.
Yeah.
Oh, it was not a simple random sample. So they weren't met?
No, because it was specifically at BYU, Idaho.
Oh. Oops.
Okay, so compute the test statistic. See, I have, hold on. Oh no, you froze again.
No, I'm right here.
Okay. You froze for a second. I was like, no! Okay, for this one, I don't even know if my numbers are right. I opened up the one thing that he had, but is that the right file?
The class survey? Yeah, I think so.
Okay, what numbers are you using? Because there's so many.
You use the wages.
Oh. My eyes are scanning over it, and it skipped wages. Wow. Okay.
Yeah, it was confusing to me.
I know, I opened it up, and I'm like, that's so many numbers.
Right?
Yeah. Okay, so for test statistic, I got 18.133.
I got 1.836.
Oh my gosh, hold on. Just kidding, hold on. Where is it? Okay. Oh, just kidding, hold on. That's why. I'm not getting that.
No? Are you doing an independent samples test? Because the first time I was just doing a normal t-test.
Oh, yeah, that's my problem. Man. Okay. Give me 2 seconds. Okay, yeah, I got 1.836.
Yep, that's what I got too. Okay, and then for degrees of freedom, I got 98.263.
Okay, that's what I got too. Okay, so the p-value in alpha, I got, let's go back, 0.069, and for the alpha level, 0.05.
Yeah, and then we're gonna fail to reject. So we don't have sufficient evidence to say that there is a difference in means between the wages of men and women.
Yeah.
BYU Idaho.
Okay. Now let me look for this one. Okay, it says, rather than testing a hypothesis now, say you wanted to just estimate the difference between female and male at 95% confidence. So create a confidence level. Hold on, let me look at it. Okay, negative 0.17622. Does he want us to go that far? And then 4.52858.
Yeah, that's what I got too. And then still the, oh, apparently I did not understand. I would not have gotten the answer without looking at the answer key on that one. But apparently there's still insufficient evidence using the confidence interval method because it's 0 is included in our confidence interval. Interesting.
Okay. In a short paragraph, describe the actions you feel should be taken based on the statistical results. Hold on, let me go back. I'm rereading. I'm not even sure.
I probably wouldn't do anything because there's not a difference. So.
Yeah, that's what I'm thinking. I'm like, how can you get a difference? Okay.
Cool. We ready to do this?
Yeah, let me just open this up.
Yeah, I have to open this up.
Okay. I'm just trying to get all this stuff together.
Yeah, that's fine. I'm gonna go hit a button on something real quick.
Okay, no problem. I'm just reading through this really fast. My Excel sheet is just opening up weird, so I'm trying to figure it out. That's why.
Yeah, no, that makes sense.
Okay, hold on. Now it's just opening up as the simple t-test.
Oh, weird.
Yeah, so now I'm trying to figure it out. Ugh. Hold on, let me read this part. Can you, are you using Excel?
I'm using SPSS.
Oh gosh, okay, hold on.
I have to change it better.
Bear with me for 2 seconds.
Yeah, not a problem. If you remember right, Monday mine wasn't working, so I completely understand.
Yeah. Okay. Oh, okay, hold on. I think we're good. Okay, we're good. I think, hopefully.
Cool.
We'll find out when we start pasting data. Okay, Okay. What requirement? Are you ready?
Yeah.
Okay. What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Both A and B.
Yeah, that's what I got too.
Okay.
The test statistic for a hypothesis test comparing two means with independent samples is a t-score.
Yep. Okay. If two samples are independent, if knowing which subjects will be in group 1 determines which subjects will be in group 2, or knowing which subjects are in group 1 tells you nothing about which subjects will be in group 2. The second one.
For questions 6 through 11, paste the values listed here in software. This data represents simple random samples of dental bills at a dentist's office in Idaho Falls and a dentist's office in Rexford. Use null hypothesis, their equal and alternative hypothesis that mu1 is less than mu2 with level of significance 0.1. So, copy and paste time.
Whoever was smart enough to make software that computes numbers like this, touche, because I would never have been able to do this.
And I'm glad we don't have to do all of this stuff by hand.
I know. Okay, so I got, is it asking for degrees of freedom? Yeah. I got 37.996.
Okay, and I will tell you what I have in just a second. Because I was fighting with it. Of course.
That's okay.
Let's get like all of these numbers or something. Whoa, what is going on here? Oh, cool. Then, wait, let's see if I can do it over here. What is going on here? Okay. Sorry.
No, you are fine.
Howard. This is not set up the way that SPSS needs it to be set up.
Oh.
I teach myself how to do it in Excel this time.
No, it's fine.
Okay. Now I need to delete the blank. Maybe this will work. Let's see. Transform. Automatic recode. 2. 3. Code. I. C. Okay. Analyze. Learning. TK. 2. What is not allowed in the test?
What?
It's fighting with me, as per usual.
No.
I don't You understand why it hates me? Okay, now this should work. What in the world is a string variable, and why are you mad about it? Okay.
Nah.
I'm really sorry. I don't know what this is doing and why this isn't working right.
Rebecca, it's fine. Just relax. It's fine. Breathe.
Sorry. I'm really easily stressed today.
Dude, we all have those days. It's totally understandable.
Now, I just feel bad that I always take up so much of your time by fighting with this stuff.
Rebecca, seriously, no. No worries at all.
Okay. All right. Take 2.
Okay.
Second time's the charm today. Because it's not going to take 3. Okay. So, copy.
No, if you were like a mean person, maybe I'd be like, okay, this is so dumb, like hurry up, but no, you're so sweet. I had a girl last semester that she was just horrible, and I'm just like, I don't even want to talk to you, like, but you are not like that at all, so don't worry about it.
Thank you. Okay. And now we're going to do that, and now I need the other set of numbers. So I do a lot of like developmental psych classes, and one of the things that preschoolers do a lot is talk to themselves and talk themselves through every step. And then I'll be doing something like this, and I'll be like, wait, I'm being like a preschooler. I'm talking myself through every step.
Sometimes it helps.
I feel like when I talk myself through it, I can determine where I'm making the mistakes. Okay.
Yeah.
Now, variable 2. I'm going to code IF. Name. Okay. Analyze. Analyze the first one. Haha. Yay, it worked! Okay.
Yay.
So the first question is degree of freedom.
Yep.
Okay. What did you have?
I got 37.996.
Me too.
Okay, good. Okay, and the standard deviation, I got 206.637.
Okay, that is. But I got 2.
That's what
right,
you got.
we only need them for the first. We only need them for what? List 2. Okay, yeah. 206.637, you said, right?
Yes.
Okay, that's what I got too. So
Okay.
what is the test statistic? Well, I got negative 0.434.
That's what I got too. Okay. The p-value, I got 0.667.
Okay. That's what I got too, but mine is two-tailed and the test is only one-tailed. Is yours two-tailed or one-tailed?
Mine is two-tailed.
Okay, and we only need one-tailed, right?
Oh, just kidding. No, mine's one-tailed.
Okay, yours is one-tailed?
Yeah, and the p-value doesn't change because at least on mine, if I have it as if I have mine as a two-tailed, it says 0.667 because you round up, and then if I have it on a one-tailed, it's still the same.
Oh, interesting. Okay.
Because on the okay, let me explain really fast so I'm not like on the on the two-tailed, it's 0.6665. And on the one-tailed, it says 0.6667. So you still round that up. That's what I got anyway, so I hope it's right.
Okay.
Okay.
So what is the correct decision based on this evidence? And we're going to fail to reject, right? Yeah.
Yep.
0.10. Fail to reject.
Okay, suppose your alternative hypothesis is mu is not equal to mu. What is the correct decision based on this evidence? So I still have, it's still failed to reject.
Yeah, that's what I think, yeah. Okay, more pasting. For questions 12 to 15, paste the values listed here into software. The first data set represents the number of times freshman students from Utah cook their own dinner in a month. The second data set represents the number of times freshman students from Colorado cook their own dinner in a month. Use the fact that freshmen from Utah cook dinner for themselves a different number of times than the freshmen from Colorado. The null hypothesis is that they're equal. The null hypothesis is they're equal. Use the level of significance, A equals 0.05. Okay. So.
That's weird. On mine, I have more students for Colorado.
Oh.
Is that right?
I don't know. I don't have mine copied yet.
Okay.
I'll tell you when I get it there, though.
Okay.
It's the same. So I have 12 students for Colorado.
I have 12 for Colorado and then only 10 for Utah.
I also only have 10 for Utah.
Okay, good. Okay. Well, in that case, okay, what is it asking that it's equal to? So it's going to be a not equal to, right? Okay. Okay, so what is the appropriate alternative hypothesis not equal to? Right?
Because we're saying that we think that they cook a different number of times, right?
Yeah.
Okay.
And I'm asking that. So for the T, I got 0.845.
That's what I got too.
Okay.
Okay, and for p-value, I got 0.410.
Okay, I got, mine's 0.4107, so do we round up?
Yeah, it says to round.
Okay, then 0.411.
Mm-hmm. And what decision do we make once again? We fail to reject.
Yes. Okay. Give the 95% confidence interval. Okay, I got negative 2.214.
2.214? I got 2.204.
Oh, mine says 1.4.
Arg.
Ugh. What is your other end?
5.137.
Oh my gosh, mine's 5.147.
Okay, why are you going?
Oh no. Okay.
Okay, where are we different? So what is your mean for the students from Colorado for the first day?
16.667.
Okay, me too. What's your mean for the students from Utah?
15.200.
Okay, me too. So our numbers are the same.
Okay. Okay. And your confidence level is set to 0.95?
Yeah. It's so weird.
Okay. Okay. What's your standard deviation?
1 point. Oh no, that's standard error. That's not standard. Yeah. 1.736.
Okay, well that is definitely where we differ.
Okay. I don't know if that is my standard. No, I don't know what that is. The standard error of difference.
My standard deviation is 3.42 and 4.517.
Oh yeah. Those are what I have too. Yeah,
Oh.
Okay, I was reading you the wrong thing.
Oh, okay. Okay, where are we differing? This is the worst.
It could be rounding by our different things too.
Yeah, so what do we put?
No, we can go with yours because I don't know, maybe Excel will be closer.
Okay, if it's wrong, it's not my fault.
Yeah, no, it's fine. Okay, what was it?
Okay, I got negative 2.214. And 5.147.
All right, let's see what happens.
Okay. Oh, sweet. Okay.
Oh, okay.
Okay.
So the p-value, we probably should have divided it by 2.
Oh. That makes sense.
But other than that, we did good. So
You did
that's
good. I'm happy. Can't say I'm complaining. Okay, so what time do you want to meet next week?
Doesn't matter. I'm free on Tuesday after 7.
You're free on Tuesday after 7. Okay, then let's just plan for Tuesday at 7:15.
Okay, that works.
And I don't know until after tonight if I have a soccer game, but I will let you know.
Okay, sounds good.
And then we'll talk about it and figure it out. But Tuesday at 7:15.
Okay, sounds good.
Okay, see you then. Bye, Rebecca.
Bye.